Hello, welcome to the Unit 3 Part 1 review video. This is on equations of linear functions. So what we're focusing on in this part of our unit is graphing equations of linear functions and the three different forms of the equations of linear functions. So let's start there before we do any problems. The three versions that we have of a linear function are slope-intercept form, and that is y equals mx plus b. The second form is called point slope form, and that is y minus y1 equals mx minus xy. And the last one is our standard form, and that is ax plus by equals c. A and b are your rates. C is a total. A, b, and c are positive or negative whole numbers. We call that an integer. And a has to be positive. In point slope form, x1, y1 is a point, and we know that m is our slope. In slope-intercept form, m again, that's the slope, and b is our y-intercept. All right, let's get started. So it says which one doesn't belong. So if you look at these, they're all in point slope form, and they all have the same slope of a 3. So point slope form isn't really a good comparison because when you write point slope form, you can pick any point on a line. So for example, if I had this line right here that has an x-intercept of 1, a y-intercept of -1. This point might be -1, -2 over here. -1, -2. This point might be 2, 1. I could write point slope form with either one of those points. I could write it with the x-intercept. I could write it with the y-intercept. The slope would be the same on every single one of them, but these numbers I'm filling in could be different. I can write an infinite amount of versions of point slope form, but there's only one way to write slope-intercept because there's only one y-intercept. There's multiple points, but only one place where it crosses. So we're going to convert each of these to slope-intercept form. We are going to distribute the 3. We are going to add 5 to both sides. We are going to distribute the 3. We are going to subtract 1 from both sides. We are going to distribute the 3. We're going to subtract 4 from both sides. We are going to distribute the 3. And we are going to add 8 to both sides. These that I'm boxing in are all the same. This one in purple is different. So basically, all of these points are on the same line. 1, 5, coming from the opposites. -1, -1, and 2, 8. Those are all collinear. They all are points on the same exact line. -1, -4 is not on that line. It's not the same y-intercept. So this one crosses at -1, all these other ones cross at 2. So which one doesn't belong? This one right here. Why? Because it has a different y-intercept. All of these are the same line. Same, same, same. So we are going to be working with all three forms here. And in these first two, notice they have the word slope in them. So we're going to need our slope. I'm going to label this one x1, y1. I'm going to label this x2, y2. And I'm going to do my slope formula. Change in y over change in x. Negative 7 minus 8 divided by 3 minus negative 4. Negative 15 over 7. A negative negative makes a positive. So point slope form, again, like I said in the top, you can pick whatever point you want. It doesn't matter. I'll pick the 4, 8 just because it's first. Doesn't matter. So y minus the y value is equal to the slope x minus the x value. A negative negative becomes a positive. To get it into slope-intercept form, I need to know what b is. Now, we went over a couple different ways to do this. One way is to use an x and a y in the slope and solve for b. So I'm using y equals mx plus b. Negative 15 over 7 times negative 4 is going to be 60 over 7. 8 equals 60 over 7. And then subtracting 60 over 7 from both sides gives me negative 4 sevenths. And then I can write that y equals mx plus b. There's one way to do it. And that involves fractions. That involved my calculator. I didn't know, obviously, 8 minus 60 over 7 off the top of my head. So I'm going to show you another way to do it. And that is using the point slope form. So just like we did in number 1, I'm going to distribute my negative 15 sevenths to the x and then get y by itself. And first, I guess I can just get rid of my fraction right away. So I can multiply every single thing by 7. So that's 7y minus 56 equals negative 15 x plus 4. Distributing that negative 15, I get negative 60. Adding 56 to both sides gives me negative 4. I don't know why this is so thick. Negative 7y is equal to negative 15x minus 4. Dividing everything by negative 7. I missed something somewhere. Messed up a sign. 7y, 56. Multiply everything by 7. Negative 56. Oh, that's not a negative 7. That's why. So final answer again, y equals negative 15 over 7x minus 4 over 7. Same exact answer, two different ways to do it. One reason why I'm going to encourage you to do the orange way is because right here, I've almost got standard form. To get standard form, all I need to do is get the x and the y on the same side, make sure there's no fractions, which there aren't, and make sure the x coefficient is positive. So if I add the 15x to both sides, that's exactly what I get. And there's my standard form. My slope comes exactly from right here, right here. I already found it. Negative 15 over 7. My y-intercept comes right here. That's our b. Written as an ordered pair, it's 0, negative 4 over 7. Now my x-intercept is not something that I see in any of these forms. I gotta find that myself. So to find my x-intercept, that's when the y is 0. So an easy way to do that is to go to your standard form and plug in a 0 for y. Solve for x. So 15x equals -4 because 7 times 0 is 0. Divide both sides by 15, I get -4/15. There's my x-intercept. Now, like I was saying in the top, there are infinite ways that you can write something in point-slope form. Your slope's going to be the same the whole time, 3/2. But I can pick anything I want for the x and the y, as long as they're on my line. So I have one option down here of -4, -1. Plugging in x minus my x value gives me a plus. Y minus my y value also gives me a plus. Now, I said write 2 of them. So I'm going to pick another point right here. There's a good one, -2, +2. So I have y minus my y value equals my slope, x, minus my x value is really a plus, negative, negative. 2 different ways to do it. Horizontal line goes side to side, slope of 0. So if I graph this out, 2, 3, and I go horizontally through that, every single point along this line has the same y value. These all have a y value of 3. So the equation of this line is y equals 3. A vertical line goes straight up and down, a slope of undefined. It's not even a function. It's not written like functions are. Functions are y equals. This one's not. It's not a function. -4, 5 is right here. Vertical line straight up and down. Every single dot along this line has the same exact x value. So the equation of this line is x equals -4. And this is coming straight from the ordered pair that I gave you. All right, it says use the table to write an equation in slope-intercept form. That's y equals mx plus b. I don't see b on here. B is your y-intercept, and that comes from when x is 0. That's your y-intercept, 0 and then a number. So if I follow this pattern, -9, -7, -5, -3, it would be -1. 4, 3, 2, 1, it would be 0. There's my y-intercept. Y equals mx plus b. So how did I get my slope is -2? Well, I'm looking for my rise over my run, my change in y over my change in x. My y's are going down by 2 each time. My x's are going up by 1 each time. Change in y over change in x is -2/1. If I wanted to get this into standard, all I would do is bring this 2x over to the other side. 2x plus y equals -1, if they had asked me for standard form. Again, slope-intercept form, so I'm going to take my slope and take my y-intercept up 1, 1, 2, 3, 4, 5. My slope is 1/5. My y-intercept is -4. Writing x and y-intercept as ordered pairs. Remember, x-intercept has a y of 0. Y-intercept has an x of 0. See you in the next video for the rest.